Hello, I'm Jack Rickard, and this is Electric Vehicle Television. I'm here with my compadre and consigliere, El Breno Noto.
It's good to be here, Jack.
What do you know?
Well, it's raining in Missouri. I guess everybody always likes us to start with a weather report.
I don't think so. In fact, I'm somewhat discouraged. There have been a lot of comments about you, Brian.
There has.
Yeah, apparently you're pretty long-winded.
Oh, I
and
know.
the show goes on too long.
I know.
I've heard it over and over this week. I guess we are getting close to 3 hours long. So let's move it along. We got to go at a better pace.
Let's move it along. All right.
They have important people to see and things to do, and they don't have time for us.
All right. We just need a bell. Ding, 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 ding,
ding. Let's come out the gate. What are we swinging at?
Let's see. Well, the EPA did do their average fuel economy for, I guess, the 2013 fleet. Mm-hmm. They just released it this week. 24.1 miles per gallon across the entire fleet.
That's going up.
That is half an MPG improvement from 2012. Mm-hmm. Cars are at about 28.3 gallons, and SUVs and crossovers are actually doing pretty good, 24.5.
What's the cars?
28.3.
28.3. That's pretty good.
And SUVs are doing 24.5, like the crossovers that meet the emission standards for cars.
So why are we down around 24 for the fleet?
It's the, let's see, sitting at the bottom is the Chrysler Fiat automobiles. So those are some of the big, like Hemi-engined and the Dodge Rams. They're at 20.9 gallons. Okay. So it's pulling it down, pulling the average down.
Mm-hmm. So about 28 miles per gallon.
Yeah, about 28.
On the average car.
Yeah, on the average car, about 28 miles a gallon. Mm-hmm. Yes. Let's see. You know, we talked about with Anna. Mm-hmm. He had to get the Siemens motor and all that certified, I think, by the TUV or one of those.
MOUSE, something.
Or something like that. And it looks like that the TUV Rhineland is going to be certifying all the connections and standards and things in China. So the German standardization company is going to be in charge of making sure that all the foam poles and the cabling, some of the interconnection, and some of the charging stations themselves comply and are interoperable in China.
Ah, very good.
So they are going after it pretty big time. The Chinese are looking for a big move.
What's next?
Well,
they're in a hurry, Brian. They have very busy lives, and we're slowing them down.
Okay. Well, then, hell, let's just talk about Tesla.
Well, let's jump in.
It's just too much pressure, man. Let's just talk about Tesla.
So which one of us won the raffle?
Neither.
Neither.
I don't know. I thought I'd get a cake or something. I did nothing.
I thought you were onto something.
I didn't get a damn thing.
I think they'd have been better off if they'd have done it our way.
I know.
What is this P85D?
P85D, I guess what, like an all-wheel drive, 2 motors, one in the front, one in the back. Still room for 7?
Yeah. Yeah. It gets another 10 miles range.
I understood. Yes, I understood. Yeah, another 10 miles, and it's faster.
Well, it gets the top speed's up to 155.
Okay.
Anything over 80 being a felony in all 50 states except Texas.
Except Texas, yes. I did remember doing on an 80-mile-an-hour road in
Montana.
Texas. Yeah. Yeah, Montana.
155 miles an hour. What's that about? And now it does 0 to 60 in 3.2. 3.2,
yeah.
That's nothing but murder.
That's
going to hurt somebody.
That's fast. Yeah, and
that's mostly going to get people in trouble.
Yeah, it'd be good to know how to drive going that fast.
I'd say under a 6 second 0 to 60, you need to be a trained driver.
That's right.
I don't buy this.
Parts break too.
Yes, and then, all right, all-wheel drive. I could use it in the snow, but here's the thing. It's now
it's even more.
We're up to $135,000.
Now we're up there.
Yeah, it's way up there.
Yeah.
I'm gonna go out and slide around in the snow in this thing.
Man, when was the last time we did? I think that was one of my marriages. We drive the Jag, the XJ7. I wish we would have had a chauffeur, to be perfectly honest.
Yeah,
Would have made the rest even
if
more
it
fun.
rains here, I leave the Model S in the garage. We drive something else.
Yeah, right. Yeah.
But the big problem I have with all this is an alarming illusion, and Tesla admittedly did not invent this. Mercedes-Benz and BMW have been talking about this for some time, and that is certain autonomous driving modes.
Okay.
Tesla
and that was the
is
other
now
thing,
censored up 16 sensors, a laser range finder, a sonar range finders.
Bat phone?
It can bat phone. It can read signs and slow down to accommodate the speed limit, and I assume speed up and accommodate the speed limit.
Yeah.
If you put on your turn signal, it changes lanes for you, as if you didn't know how.
Oh, man.
I don't get the point of this, and here's why.
Okay.
Last week we talked some about litigation,
Yes, we did.
and it's true that there has been some over vehicle defects, as I pointed out then, mostly over the cover-ups, not
right.
the defects.
Right. No.
There was usually, by the time it ever came to trial, no question about the size, nature, or kind of the defect. It was all about what they had done as a corporate citizen to cover it like a kitty burying scat and keep from having to take responsibility for it in the most scurrilous fashion.
Yes.
In our society, in our automobile society, probably 2% or so of the accidents can be said to involve some sort of a mechanical failure.
Okay.
Now, that's not necessarily a defect. It could be just it's an old car and the brakes failed.
Sure. Right.
Or I was driving down the road and an axle and a wheel came out of an old pickup truck, Datsun pickup truck, right out in the middle of the road in front of us.
Yeah, what do you do? Yeah, I saw the drive shaft dropped out of a car the other day here, yeah.
And so you have things like that, but they're very small percentage. Most of the accidents are a function, and this is very well known, of operator error.
I would imagine, yeah. Just somebody not paying attention. Yeah.
And so we have a whole insurance system, and there are numerous court cases about people causing property damage or loss of life through their errors in operating a motor car.
Sure.
The presumption, of course, is that they were driving the car.
Yeah, that you
And you
were in
almost
control.
never hear of an OEM being involved in it if there's not a significant defect in the car's design.
Right.
And that's very rare.
Yes.
When you start putting on autonomous driving functions, like slowing down and stopping before you hit the car ahead of you,
Yeah.
then if I relied on that to work and I hit the car in front of me, who would be at fault?
It would sound like could be a couple of parties now.
There could be.
There could be a couple of parties.
And it reminds me of the story of the airline pilot that came back and wrote up a maintenance ticket on his aircraft that noted the Category 3 Autolander was pretty rough.
Okay.
And the mechanic signed it off that this particular aircraft model doesn't have a Cat 3 Autolander.
Oops.
Problem being the pilot thought it did.
Nobody was landing the plane.
Now, when you start changing lanes, avoiding obstacles, this sort of thing, changing speeds as a function of the car, what part am I as the driver supposed to do, and what part does it do again?
Yeah, it's a very blurry line. Yeah.
Did I read the book correctly?
Yeah.
Officer, I thought it would stop itself.
Yeah, I just took my hands off
It's
the wheel.
on the website. Elon said it would.
That's right. Yeah.
And so it clouds. It doesn't cloud. It very legitimately brings into question who is responsible for the accident, the car or the driver. In the past, we haven't had this. The driver's responsible. and the automobile manufacturer is presumed innocent until some mechanical failure becomes evident. And it has to be something that's not a routine wear and tear. It has to be a design defect.
Right, the one they would cover up.
Manufacturing defect.
Yeah, one that would cover up.
One that we would cover up like kittens with their scabs.
That's right.
And so they've had pretty free pass on accidents.
Yeah.
Why would they want to open this up to become part of the entire litigation ecosphere having to do with operator error in automobile accidents?
Yeah, and it brings in pockets other than insurance companies. Now you brought in the manufacturers too. I mean,
Yes,
wow.
it's very bizarre. The insurance company does not have to cover this if the manufacturer is there to
Sure.
cover it.
Yeah, yeah, they're the back stand behind it. Yeah.
Why would you introduce these features and expose yourself to that sort of legal exposure? If, if the car is driving itself, the guy that designed the car becomes responsible for its activities.
Yeah, if it's taking control from the driver. I mean, if it can take, I just wish they would have given us a flying car.
I can imagine that, the problem is, of course, that this house says everybody lies. Everybody that has an accident is going to claim that it was the car did it itself.
The car did it. It
I
jerked
was
the wheel.
fighting to stop
Jerked
it.
the wheel out of my hand.
Jerked the wheel out of my hands, and there was nothing I could do. I lost complete control because the car wanted to do its thing. So I'm surprised about that, and I think that's something going into the future that we want to keep an eye on. I think it could be an issue.
Okay.
And I think it may be an unnecessary one. Why do we want cars to drive themselves? I mean, I get it. I was there in the 50s. Roy Rogers would whistle for his horse, and Trigger would come get him. Cool. But you have to train your car to do that.
Yeah, exactly.
And and what if it runs somebody over along the way?
Yeah. Bummer.
Bummer. Because you called it or because they made it?
Yeah, exactly.
And so I think that's kind of a deal. We last week had a whole show planned, and we wound up being 2.5 hours with half of it.
I know. We were.
And then I've received actually some in-person comments. Bill Bayer's dad was down this week, and on the website, hey, you guys are doing great stuff. If you weren't so long and old and fat and boring,
If we could stay awake.
oh well, fan club.
I know. Come on.
Yeah, just no, stay behind the ropes.
That's right.
What am I
We need
supposed
some
to do
velvet
with
ropes.
that? Quit and go home? Maybe. We'll think about it. Anna had sent in a great segment last week.
Yes.
That we bumped to this week because of the, we got carried away.
Yeah, we got time
Bringing
constraints.
in Anna from Amsterdam in the Netherlands,
Right.
our EU warehouse and partner, Supremo.
There we go.
He's doing some cool things. Let's take a look.
Well, hey, EVTV. Here's Anne Kloppenborg with that weekly EVTV Amsterdam update. This week, we've had a hard time to keep building as there's many projects up in the air, and we are getting ready for that big move I've been talking about for a while. In the last 2 weeks, the old shed that was in the location where our new warehouse will be has been torn down. The ground has been plowed. The new concrete has been poured, and all the preparations for the new warehouse that will be built next week in 1 week's time have been made. There's a lot of contract negotiation going on, a lot of sourcing my heaters for the next cold winter, and getting ready for all that good stuff that is the mild cardiac arrest, which moving always entails. Then again, we're very excited because having a lot of new space is going to be needed. There's a lot of projects coming up. A lot of folks want to come help us do the building. And right now, as you can see in our little space, the original garage where it all started, we just don't have any room anymore. Every day starts with putting 3 vehicles out so we can work on vehicle number 4. Raymond's got his corner to work. I've got my little office upstairs. But even if we had guys wanting to help us out, there's no real space for you to work, guys. So we really need that move, and we're very excited that it's actually happening. That said, what else was happening this week? Well, one of the big new projects that we are hopefully going to do is a great Volvo 240 conversion, possibly for Mr. Lubbers from Fastned. Fastned is a company I've talked about before. They have 200 concessions for fast charge stations all along the Dutch highways. 200 stations at strategic locations where normal gas stations are already there, and they'll have their separate parking slip. A few are already active. I'll show you what they look like again. So they have their second separate slip in these areas where normal gas stations are, and they offer 3 different standards of charging. It's a big ABB made box that offers both a Chademo plug, a Type 2 plug, and I believe a normal Schuko plug, if that is the case. Maybe it's just Type 2 and Chademo. I'll check it out online, and I'll put it up left or right, wherever I've got some space to put that graphic. Anyways, Bart Lubbers is one of the original founders and organizers of Fastned. And of course, being the director of a company that is introducing fast charging as a national grid network here in Holland, he feels that he also should be driving electric himself. Now, he's no stranger to driving electric. He drove a electric converted Lotus done by ECE Cars, one of the first road legal made in Holland, converted in Holland, electric cars that were around back in the day. His dad, our former Prime Minister, Ruud Lubbers, drove one of their converted Golf cars, which is not a golf cart as in the sport golf, but Golf as in the Volkswagen Golf, which is a very popular Volkswagen model here in Holland. And it got about a good 150 kilometer, slightly under 100 mile range already back in the day. Because Mr. Lubbers, of course, he'd be able to get a Tesla, and even though it doesn't have Chademo standard charging, he'd be able to do Type 2 charging. But he says that it is simply the Tesla is not really for him. It is a very swanky car, and some people like their cars, with a little bit more character, a little more history, or some different lines, and so the modern offering of Tesla or BMW are not for him. The wife doesn't like the looks of a Prius or a Leaf. And they've always actually been Volvo drivers, having a quite a sizable family, and needing to get the kids in the car and the groceries and the dog. They'd like to have a car that's more practical and suits their tastes. So, using our conversion components, it's basically you choose the car and we'll make it roll. And in this case, we're going to be offering a complete set and conversion for a Volvo 240, and hopefully getting him out on the road. Now, part of what he wants would be Chademo charging. So, as part of our offering, we will have to see if we can make the car Chademo ready. I believe, from what I've been sniffing around on the webs, that that should actually be quite possible. And I have slightly more confidence in that we'll be able to make a fitting proposition for Chademo charging, enabled charging in a conversion we do, because we have Celso Manaya of Portugal coming over to Amsterdam. Our shout out last week had the intended effect, and Celso and I got in contact this week. And Celso will be coming over from the 15th till the 29th of October. So I will have his wisdom and talented fingers with the batteries and the wiring here for the 2 weeks prior to us getting this Jeep road legal tested. So that's going to be a great boon to us while I'm overseeing the move. Celso will be taking charge of a lot of the wiring and final fitment for components, getting this car road legal and getting the GevQ all set up to go. And so that's a big relief. But at the same time, I will be picking his brain, and through his Portuguese connection, talking to Paulo Almeida and seeing what we can get done on a Chademo unit. making a conversion that we make at Chademo charging ready. Then as a backup, he will also have a Type 2 plug, probably at first hooked up to a single 3.3 kilowatt charger, and maybe at some point giving him the full Type 2 20 kilowatt AC option as well for when he's more in cities and not on the move. So, good projects, and at the same time, good movement on our shop and business development front. What else was coming in this week? Well, I am sitting next to some beautiful 180 watt panels. Thank you, Richard Flenchy, for packing them up beautifully. And we now have a air bridge in effect. I've talked about the air bridge before, but it's never really worked out. It's always, supposedly, it's supposed to be affordable and a week. And I always ended up with this gigantic bill, and it would take like 2.5 weeks trying to get something through customs, or something would sit in Chicago for like 3 weeks with pilots saying, that box, nah, I'll leave it. So it never really worked out as it was. Here I was hopefully offering the customers a quick to and fro for an acceptable amount of money, and things would end up taking a lot of time, costing a lot of money, and I would always kind of shy away from offering people this option even. But now we seem to have the whole UPS thing down. I have some direct account manager contact here on the Dutch side. UPS has so far not screwed up things on the American side, and that means for all our viewers out there that in addition to the stuff that we try and keep in stock, stuff like the JLDs, the fuses, a couple of the motors. But, Jack's amazing knack for finding great EV components means that by now the lineup is so big, I'm not quite able to either keep up in tempo or keep up in volume. But at the same time, I don't want to disappoint people when they need stuff, next week or 2 weeks from now. With the air bridge, we'll be able to get you, something that I don't have delivered to your door probably in about 2 weeks' time, counting the week it'll take to get over here, repacked and paid, and out to you. That's a lot quicker than the 6 to 8 weeks that it would be when things get packed into one of our containers as they come in bulk from Cape Girardeau over to Amsterdam. These 180 watt panels being an example, they're all going to one of EVTV Amsterdam's best new customers. He's been at it for a while, actually. This is a guy that runs basically the front end of a shipyard where they supply and do a lot of stuff for many of the smaller to mid-sized commercial operators out here on the canals in Amsterdam. So that'll be your saloon boats up to and including some of the larger canal, what we call the glasbakken, the big canal ships that take all these tourists around the beautiful canals of Amsterdam. This guy is very well known and for doing electric conversions. A lot of the newer companies, if they want to get into a piece of this pie of taking around tourists, they need to get a license, and to get a license by now, a new license always has to be under innovation. Innovation means no emissions and or even using solar panels as a part of the mix of getting the energy generated, and definitely having no emissions while floating around. We have our next container probably coming, 2 or 3 weeks from now. It'll be loaded, another 6 weeks until we have it. So that just didn't cut it for him. And we needed to get this UPS airbridge thing going again. Well, luckily we have them here. These are ready to go. We had a shipment slightly before. And as I was tooling around Amsterdam this week, I saw one of the boats that some of the earlier 24 had been mounted on. So you will get to see what that looks like. EVTV solar panels. So there you have it, 6 180-watt solar panels on the top of a saloon boat here in Amsterdam. Panels with cells made in the States, manufactured in China, sold on through the States, and installed here in Amsterdam. It's a wonderful globalized world, but take away all the shipping around, we're getting these clean power generating components out there in the wild, and it's all due to EVTV components being the best and at the best price in this range. Even though there's generally a will match your higher price guarantee, these panels actually are very sharply priced for what they do. The guy installing these, 6 of these on a boat, so 6 times 180 watts, laid out flat on a boat, non-ideal for mounting. Arjan Koyman, our customer, was getting as much as 1,000 watts continuous, so that's a kilowatt continuous, off of these panels as they were installed flat. Now imagine, here in Amsterdam, we're up in Toronto, okay, as far as you're concerned in America. We're up in Toronto, so that's high latitude, longitude. I've never been good with those. Well, it's up north, guys. We don't get that much of an intense sun, and yet 6 of these panels out flat, some not even in the sun, we're producing a continuous 1,000 watts. So that is a very high efficiency and conversion rate for anything mounted like that. And the customer was very enthused and is ordering more and will be ordering more still in the future. So these things are great. Well, has it all been preparation and me talking and shipping stuff? Not quite. We're a little further along with the Jeep, as we need to be. 3 weeks from today, from next Monday, we'll have road legal testing. The Jeep's all put together. That's not because everything under the hood is done, but it's because we'll be sending her out next week to a Jeep specialist. There is a lot of rack and pinion stuff that needs to be done. She's going to get new brakes. We're upping the weight a little bit, and during part of the road legal testing, they're going to do heavy brake testing to check if this weight change still leaves the vehicle safe. So we need to make sure, and the brakes were kind of tired already, but we need to make sure that they behave properly, or all the effort will be for naught, and we have to make a very expensive appointment to get her road legal tested again. So rather than risk that scenario, we're sending her out to a specialist who also will check her point by point on all the other, what we call APK, the general road legal testing procedure. That doesn't have to do with the electric drivetrain. It's, it's wiring, it's lights, it's play in the steering wheel, it's brakes, it's quality of tire. It's making sure that the defroster works. Actually, that's something we did install. So I will quickly take you around the Jeep and show you the components that we've been putting in this last week. Here's a Pierberg liquid cooling pump with a custom-made mounting frame that Raymond did up in the same color, as you can see the frame of the Jeep is. So we'll be able to mount this nicely under the bonnet and get that hooked up to our motor system. Here is a Type 2 inlet port that we will be using, which is needed because we're not allowed to charge with a plug that you can that can be reined into and that can't be closed off. She's a slightly bit plastic, but this is what we can get right now. And even though she's a bit of a cheap plastic, 200 euros for this little baby. Come on, guys. It is a piece of plastic. A couple of colors on it. But as volume goes up, prices will go down, we do hope. Of course, we have our trusty Ferraz Shawmouth fuses. And I'll take you around the car and show you some of the other components. So under the hood, we've installed a few more doodads. Here is one of the So there is one of the PTC space heaters. This one is rated for the 300 plus volt range. It's sitting where the original air duct would come along here, and it would be a blower that was heated by engine heat. Now, of course, we're going to be heating electrically. Even though this is an open car and it's not like you're going to be properly heating your cabin area, it is a road legal requirement that you can defrost your windows. So we do need to have a blower. There's an air sucker blower behind there, then there's the ceramic or the PTC unit, and then this little fan at the front, and we'll put a little air duct out to the front grille and make sure it gets its air properly. Sitting here is one of our big 1000-watt Chenic blocks. That will be our DC-DC converter. So it will be getting its high volt from the high volt switching box that will reside over there, and it will be giving out its 12 volt to a 12 volt that we will put up there right next to the 12 and 24 volt breaker box. This car, being an old military-style Jeep, actually has all of its lights on 24 volts. Yay for us! So we'll be using a 12 to 24 step-up DC-DC converter as we're going from high volt through the DC to 12 volt to 24 and getting it all working that way. So here we have the former gas tank inlet, and that will now be housing our Type 2 inlet. It'll be mounted from the rear, and only the little cap will stick out the front, and you'll be able to open her up and stick in your Type 2 charging cable. Inside the cabin, we've mounted our trusty JLD 404 right there, and we'll be able to see the amp hours in and out, voltages and amps, of course. And if you can see over there is our breaker switch, emergency disconnect switch that will use a 12 volt relay to connect to the contactors that can break the high volt battery pack. Also another road legal requirement when it comes to bringing an electric car out on the road here in Holland. What are some of the other things we need to do? We need to have a indication for gear here where the Jeep knob is. That's not allowed anymore. And also we're going to have a pressure sensor in the seat so that if you leave the car while the controller is enabled and you are in gear, you will get a pung, 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 very annoying little noise. But it's necessary because otherwise she will not be road legal. There's Taz up on her back, and now back to me sitting and talking to you. And then next week I'll give you a nice update of what our new digs will look like. At the same time, hopefully we'll have some news, not so much great news, some sad news really on the Tesla slash right to repair slash owner's rights front. Kevin Sharp, a EVCON attendee this year and good friend of ours here at EVTV Amsterdam, has been a Roadster owner and driver and proponent, Tesla proponent and fanboy of the first hour for years and years. He has a Tesla Roadster that has done over 50,000 English miles. And he has not only purchased that car, taken it around many different shows, showing people the fun of electric driving. But he also has the extended, very expensive extended warranty on the battery pack. And yet for all that fact, he has problems with the battery pack that by Tesla is being deemed as normal degradation. I'll go into it into more detail next week, as there's quite a hoo-ha online about this particular case and more like it. But basically, Kevin Sharp has logs of a particular section, brick 8 of 12, I believe, that has been underperforming actually since day one. And you can get logs out of the car, and it shows that it was already underperforming before he, in fact, purchased the car. Tesla is giving him the cold shoulder, though, and they're not covering it by any ways of warranty while his range is sharply declining. And it bodes us to worry a little bit. We hope that they'll come around and that maybe it's more of a corporate culture, translation, maybe a limited availability of either new cells or available working capacity. We're not quite sure. But anyways, next week we'll go into that into more detail, get you updated on some of our other builds. In the meanwhile, I hope you're all building. We're going to keep building, even if it's just a new warehouse. And I'll see you next week, guys. Take it easy.
Life is about making decisions. At BMW I, we decided it was time to reinvent the car from the ground up, making sure we were open for truly innovative ideas. We decided that the car we wanted must be electric, and it should be made of extremely light and super strong carbon fiber. And finally, we decided to make it more intelligent and added our promise of incomparable driving pleasure. We made all these decisions to offer you a choice. The all-electric BMW i3.
As always, Anna's been busy.
I watched it last week. What was it about?
What did he do? See, guys?
One of the things he did was he has a customer who's going to do a Volvo with.
The Volvo, yeah.
Volvos are very interesting cars. That's your make
That's what I
or
have right
mark
now, yeah.
that you like. But for a number of years, Volvos were rated the safest passenger vehicle in the world. I mean, for like 20 years.
Yeah, that was their trade, yeah.
And so he's got a neat build going there. His deal was, and all week I had people ask, hey, was that a Chademo connector you had on the table that you never talked about? I said, we did, and we didn't.
That's right, we did and we didn't.
And so he wants to put that in a car. You know, I do too, and I have for some time. Things are kind of coming together, but I want to go take a look at Polo and Kelso and kind of weave that in together.
Okay.
Let's take a look at this.
Hello EVTV.
Hello Jack and Brian.
Here we are again from Portugal with an update on our GLD project. This week we're going to show you our test vehicle that we are using to test the GLD setup. It's a minivan made by Piaggio.
Made by Piaggio and in Italy. They did this conversion. It had lead-acid batteries. It has a SEPEX motor and a controller, a 300 amp controller from Zappi.
So let's take a walk around it and show you guys what we have here. Okay, the thing here.
This is the van. It has all the controls under the front seat. Batteries, the JLD, the shunt, and the DC-DC converter. We have 34 40 amp hour batteries for a little over 100 volts.
Okay, and here we have a small application that I did in LabVIEW that will talk to our GLD over Bluetooth. So we are inside the van.
Yeah.
Celso is the driver, and our JLD is back there. I think I can't get it on the picture, but next to the battery pack you saw earlier. So to make this run, we just click here on connect, and it should hook up. Okay, we are hooked up. Celso, let's go.
Let's go.
So let's go for a nice drive around the campus in our van. Oh. Oh, regenerative braking, you can see negative amps there. Show you a little bit about our campus here. Oh, back to the JLD. Already used 0.3 amp hours. Woohoo! Downhill, taking advantage of regenerative braking here. Voltage goes a little up on the battery pack. Okay. Go down to the sports fields, so we can then try to push a little amps uphill. Okay. Oh, a little bit over 200 amps there. Too fast, I can't. I can't hold the camera on it. Okay, again, push a little amps. Okay, ooh, good. It's not a very powerful van. Let's see how many kilowatts we can actually pull out of it. Let me focus on this. Okay, now we're here at the gate, and off we go. Around 20 kilowatts peak.
We now have fuel.
Yeah.
Can give a little bit more.
Hello, hello. Okay, 27 kilowatts peak, not bad. And we are pretty much back to our starting point next to our lab here.
Next to our private parking spot.
Next to our smart conversion there. So, okay, back to our place. Hold on. So, as we can see, we lost a little battery voltage. We started at 113 and we're now slowly recovering from 110 or so. We used 1.6 amp hours and roughly 0.1 kilowatt hours. One possibility that we have on the JLD that is very useful also is we can easily reset this amp hours and kilowatt hours just by hitting the reset button, and they're back to 0, as you can see. So Celso, anything else for this week?
I guess that's it for this week.
Okay, back to you guys.
JLD 505.
We have been doing a lot on product development here at EVTV.
Yeah, we have.
We see kind of a change of direction toward a number of things. I'm going to talk about that some this show. Polo and Kelso have developed a device they are calling the JLD 505, kind of a modernized SMD component level update to the JLD 404.
Yes, yes.
We've sold one Brazilian.
Yeah, we do,
these
yeah.
things.
Yeah, you guys like those.
They're a little meter that measures a voltage, a current, amp hours, and can control things with 2 relays based on any of those measured values. Polo is with the JLD 505 has taken that some steps further. It will measure quite accurately, as it turns out, using this little A126 chip. He was using an A120. I talked him into the upgrade. It was another 22 cents or something. But anyway,
those incremental costs could kill you.
It uses a shunt to measure current quite accurately. It will measure your pack voltage. It doesn't do a number of them. It doesn't do every cell, but it'll measure your pack voltage and keep track of that. It has 3 interfaces. One of them is the USB port. You can plug in a laptop and program this thing and put things on the screen and type things into it and so on and so forth. It has 2 other interfaces. One of them, interestingly, is Bluetooth version 4.0. 4.0 includes the Bluetooth low emissions,
low
energy.
Low energy, yeah.
And that opens the door to interactivity with the iPhone. Apple's iOS has in the past kind of played games with what you could do with Bluetooth. But they did open it up with BLE, and now I think they're doing all of it. This is the new big iPhone.
Yeah, waiting for mine.
And so that little device will be able to report voltage and current and amp hours and kilowatt hours to an iOS device or an Android device, as the case may be, with its Bluetooth transmitter receiver. It also has a CAN bus port.
Nice.
And we are using CAN for any number of things. Most importantly, Chademo uses CAN to establish the link and talk about voltage and current, primarily current requirement.
Excuse me. Yeah.
The car actually runs Chademo. Now, there is kind of a handshake that goes on here, both analog and digital. I'm going to put a diagram up here on the screen. When you plug it in, your car can pick up that it's been plugged into.
Okay, all right.
It has a ground wire that basically signals to the vehicle device, in this case the JLD 505 that you're plugged in. And then what you need is a device with a little bit of intelligence that can do CAN. Two contactors, one for your positive terminal and one for your negative terminal. This is our, what do we call this? A GigaVac. It replaced the Tyco. We're selling a lot of these things. GV200MA.
Yeah,
So
those are going great.
You know, contactor capable, high voltage, high current. I think these are rated at 500 volts and 300 amps, 250, something
I
like
think
that.
right in there, yeah.
And certainly enough to do this. And the Chademo charge station actually sends a analog signal over to close those two contactors.
Okay.
But the device in the car is supposed to actually have one of those, either ground or the positive, routed through a relay that it controls so it can override it.
Oh, okay. All right.
So both sides have to agree to close the contactors, and that's on the analog side. And then you have CAN, the controller area network, and they exchange messages. And most of the conversation is essentially what level of current the charger can provide and what level of current the car wants.
Okay.
And the car continuously updates this current level, and it does the CCCV, constant current charge, constant voltage.
Okay.
It will request maximum current, basically, until it reaches a certain voltage, and it will start reducing the current request to maintain that voltage until it gets down to some level, and it terminates the charge. And so that's essentially how Chademo works. Looking across the landscape, Tesla, it's clear, are going to maintain their charge system as a very proprietary one. The levels of power they're talking about, I'm not sure that connector can handle it in any event. The SAE combo is a dead on arrival. It was stillborn, and it's still stillborn.
Yes, that's right.
And that leaves Chademo. There's actually about 1,888 Chademo charge stations in the world. If you look at a map, and I'll put one up here, of where they're at in the U.S., they're clustered. There's a bunch. California's blanketed.
Sure.
Chicago's got a bundle. Tennessee, for some reason, has a lot. And some areas of Texas. The rest of it is Nissan dealers scattered around.
Okay.
Our closest Chademo charge station is in Baldwin, Missouri, 100 miles away, 110 maybe.
Probably the ball one, yeah.
And that's kind of a problem.
Yeah.
You see, with Polo's JLD 505, which is a programmable Arduino, it's not a DUI, but it is a programmable Arduino with a CAN bus. And it has two digital inputs and two digital outputs that are essentially buffered and isolated. And so we can do all with that, all of that. We kind of have to fake one of them.
Okay.
But we can basically, with those two inputs and two outputs, do everything we need to do for Chademo on the analog side.
Okay.
With the CAN port, and it has a single one, we can essentially do the CAN part. And that leaves us really with a requirement for two contactors and with a very expensive but obtainable Yazaki inlet. Be proud that we're doing the inlet instead of the plug.
I know.
The plugs are $2,900. These are about $800. 7 something, I think, but still pricey. But I can easily see a $1,600 or $1,800 kit here.
Okay.
To convert any car to Chademo, and that happening fairly quickly. The issue is the availability of a Chademo charge station for us to test our software against.
That's true. Yeah. It's 100 miles away.
Paulo's not a software whiz, but he's got Chademo there. And Anna has plenty of Chademo. Colin and I don't.
I know.
So we've got the guys that can write the software and the guys that have the Chademo. But we're doing a lot of things globally anyway. We'll work it out. And so that's my interest in Paulo's device and Anna's need. And I think that need's going to come up more. Do I need fast charging? Not particularly.
No, not really.
I have looked around to find a DC fast charger. Well, I funded one 2 or 3 years ago that never did happen.
Never did happen.
With Ryan Bombs. But the charge stations are very expensive, starting at about $15 for unobtainium versions, and about $25 for ones you couldn't get.
Ones you could, that's right.
I did talk to Fujitsu this week. They have a nice one, but at the AC portion is so integrated with a DC control that I can't use it. What I told them I wanted was a Chademo charge station that would run from a DC power supply rather than AC. 3-phase power here is, in many cases, difficult to get.
Yes.
We sell a lot of batteries. I would sell more if I could. And so
exactly.
a battery-powered Chademo,
Right.
maybe with some solar,
Yeah. Nice.
to help charge the batteries, would all work very well. They are leaving a opportunity gap here for them and us and me, wide enough to drive a trailer truck through sideways with the pricing on these Chademo stations.
Yes, I know.
And so if we can get 3-phase AC controllers for $5,000 and PWM chopper controllers that'll do 1,000 amps for $3,000, what's between me and being able to charge should not be technically $55,000.
No, exactly. No, no.
That's a little bit of a stretch. Of course, hooked up to our own battery system, we hardly even need UL listing. We're not on the grid. I don't think you need a permit to do any of it.
I know. I don't think so either. No.
Anywhere. So the that's pretty much the thinking on Chademo. I'd like to do a DC version, and I have discussed with Paulo kind of a longer term project. I'm going to turn this out as quickly as a JLD 505, but the ability to take a DC source and play Chademo charge station, even though the plug is $2,900, that does include 20 foot of heavy cable, though.
Yes.
Which gives thieves something to whack
No,
off
they can
and
steal.
take down to the
Take down the recycler.
metal recycling shop to get $80 for my $2,900
Yes,
cable.
exactly.
What a world! What a world! What a world! Oh,
Curiouser and curiouser, huh?
Dorothy. And so there you go. And so that's what that's about. Let's. One of the reasons we got behind last week is we're doing quite a bit of things here this week. Some of them good things, and some of them idiotic things. Let's talk about the idiocy of the week first. I hath sinned most mortally. Let me show you.
All right.
We have developed kind of a following with our battery bottom balance procedure because of the fact that sooner or later you're going to somehow over-discharge your batteries, and you need to build in a way to save them when you do. We have another little incident I'd like to talk about. This is David Kurzel, Modular EV Power. He has a very capable, beautiful billet aluminum J1772 charge port. It's very good and it's very strong. However, I have proven this week without a doubt that it's not good enough and it's not strong enough to bear it when you drive away with your charge plug connected to your vehicle. Don't ask me how this happened, but I did. We pulled this completely out of the vehicle, leaving behind these 3 pins which pulled out from behind the plug, breaking the plastic that it was glued to and in there with, and totally destroyed this. We also pulled the ground wire loose, disabling the car, and some other misadventures. The cause of this, other than my Alzheimer's disease, is this is on the right-hand side of the vehicle, and I sit on the left side, and you actually can't see if there's a charge plug connected. I glibly jumped in the thing and took off, and completely ruined, actually disabled the car, ruined valuable inlet plug, and so forth. We have shown you in the past how to prevent that, but I didn't do it. And so we're going to go over a little bit today of what that means. Because we use this, we also use David's AVC2 controller. This detects when you get AC power and a pilot signal and a proximity switch, and manages your application of AC to your charger. One of the things it has is a relay, and marked on the unit, it says C on one pin, NO on another, and then C on the third. This is actually a relay, and C is the common. NC, or this is a normally connected pin. From the common to the NC is normally a short, and NO is the normally open pin. And all we have had recently, if you'll recall, added a couple of functions to the generalized electric vehicle control unit. I'm pleased to report that both our reverse and our enable switch work extremely well. It's just been flawless. I haven't really had to revisit that code since it was first cast. And we now have an electric reverse, which I find I actually do like. Putting a VW transmission in reverse is a little tedious, but it gives you very low gearing and kind of a jerky thing. If I'm in third gear and I select electric reverse, it's very smooth and very controllable. In any event, those work very well. And the enable switch, when you press it and it turns green, provides 12 volts to the JevQ, and that 12 volt signal enables it to work, drive a motor. If you remove it, it will not drive a motor. And so what we've done is wired 12 volts to the C terminal, and then connected the normally closed terminal to the enable switch and the reverse switch. So neither one of them can send a signal at all to the JevQ if we plug in the charger. And so now we can't drive away.
Bitte vorsichtig.
Captain Kirk.
Genau wie in einem Raumschiff. Faszinierend.
Volkswagen, das
Okay, I've got
Auto.
my J1 1772 connector here. I'm going to plug that in. And as we can see, our lights have gone out on both our reverse and our enable switches that are on our dash. This should prevent me from being able to drive away because I can't get an enable signal to the JevQ, and so I can't drive as long as this is plugged in. We may have another solution if you don't use Dave Kurzel's modular EV power unit. So what if you don't use the modular power Dave Kurzel's AVC system? On this thing, we have installed the Brusa charger, and that came from the Azure Dynamics auction. We also got a set of cables that include the plastic inlet and nice orange cables all the way back to the charger. But I don't have the AVC2 device. We sell in the store a thing and have for some years. It's a popular seller. We call it a 4-range digital voltmeter, a control voltmeter. It has relays, and we normally use it to measure DC voltages. It does not do current, and it's less expensive than the JLD 404. And we use them to make little automatic balancers for bottom balancing the batteries. But this has actually got another function in it to measure AC voltages up to 500 volts. And so I can connect this to that cable somewhere. We'll have to splice into it to our 2 phases and set a relay that if it detects, let's say, more than 90 volts AC, that it closes a relay and removes 12 volts from the enable signal on this thing. And so this at $99 makes a perfect little device to detect AC voltage when you're charging. And you might want to do that for any number of reasons, to apply heat to your battery heat boxes, but only when you're charging, for example. In this case, we would use it to detect an AC voltage from charging and disable our JevQ so we can't drive away. As long as you have the J1772 connected, you're still going to have AC voltage until you pull it out. And so that would work about equally as well on a different system.
Smart.
So if anybody asks, it is technically possible to pull a J1772 charge cord out of a vehicle by the roots.
I know, it's just to yank it out.
It's a matter of technique.
Yeah, that's right.
And paying attention to what you're doing.
That's right. Being oblivious. Huh?
And but we have.
Oh, man.
So we share with you. Those are 2 simple ways to avoid that, and it is worth the effort.
Apparently so. Yeah.
We have time to fix and repair and replace the entire thing, but we didn't have time to.
A couple of wires.
Put in a couple of wires. The history of this thing is such that we didn't have the enable signal.
No.
When we put all that together. So but it's coming along. That's how you would do it. There's 2 ways to do it, and they're not expensive and they're not hard.
No.
And they will certainly help you with some of that. Again, as I said, we've been involved in some product development. I have a new product I'm very taken with because it's an enabler. This is a cable. It has a J1962 Type A plug on this end and a DB9 female on this end. The J1962 is, this would plug into your OBD2 connector under your steering wheel somewhere in the vicinity to access your vehicle's CAN bus. Your onboard diagnostics port duh.
Right, yes, exactly.
OBD2.
Yeah, OBD2.
And that connects to that. This is a board Paulo has just done for me. We've had 100 of them made in China, and they've come in with the wrong gender DB9. They still don't have a very good explanation for that. The first few of them will come out with fortunately they make gender changers, and this will simply plug into here, thus and such, and this can then plug into here after that fashion.
Oh, okay.
What this board does is provide two CAN ports, one on the DB9 and one on a series of screw terminals. In addition to CAN high and low pins, this is also wired for the vehicle 12 volts on pin 16 and the chassis ground or vehicle ground on pin 4. And those are carried through to our board, and our board is a shield from our Arduino DUI. And so we can actually power the entire rig from your OBD2 socket, which is kind of a cool trick.
Yeah, not having to get any more 12 volt from anywhere else, huh?
Yeah, I'm gonna. And so it would power the Arduino board and this board with it. And this is, of course, to pass CAN traffic. Let's take a look at what I'm doing with it today. We have been wrestling with chargers for a very long time. To have an electric car, you have to have a charger, or you can only use it once. Chargers, just 2 years ago, we had the Brusa at about $3,700, the Manzanitas starting at about $2,400, and some Chinese chargers that you had to order from the factory at a fixed voltage and you couldn't change. Things are getting better, and I wanted to show you some of the reasons why. These two, well, let's see. This is a charger with a CAN bus adapter. You can order the Chinese chargers where they're CAN controlled for an extra $50. And so we have ordered a bunch and carried them and have been selling them. They come with a little CAN bus adapter. We had actually done a shield for the Arduino to talk to it directly and cut out the adapter. We're kind of going back the other direction, and I want to show you why. Here are two new ones that are also CAN controlled, but they come with two wires that come out. The blue being the CAN low and the brown CAN high, which I find mystical. But the CAN has moved inside. In addition, I've been reviewing some kind of these squarish looking chargers, much better hardware for the connectors and so forth, and they're all CAN controlled, and they use the same protocol. And so recently we have taken on the entire CAN concept, and I've got a new CAN controller here, and I can bring this up. Oh, let's start a little movie here so you can see too. We will turn on this charger, put power to it, and bring it up. And I have a little program here in Arduino. And let me bring up the monitor here. And you can see this is version 3.70. I can have the voltage to the left, and then it reports the voltage it actually gets from the charger. Then I have the current that I want it to charge at, and the current it's actually charging at. And then I've got something labeled end, and that's the current where I want it to stop. And then we track amp hours, kilowatt hours, and have a time mark. So I can change the voltage by pressing V271 and enter. Let's see, am I there? I have to go up here. V271, and my target voltage actually changes on the screen. I'm showing an actual voltage at 246 here. My current I have set for 20 amps. Now this is a 3 kilowatt charger, and it can put out 16.2, and that's what it's doing right now at 247 volts. I've got my end current set for 7 amps, so when we get to 271 volts, the current will automatically start coming down, and when it reaches 7 amps, I'm going to terminate the charge. And then, of course, we keep track of the amp hours and kilowatt hours going in. This is with any serial terminal into the USB port of the Arduino. And so we can see this. You don't need any of that. You have to get 12 volts to the Arduino and have this CAN bus adapter here, which I've got routed to here. And whenever you power this up, this program runs. You can observe it with a terminal program, but you don't have to. The laptop isn't doing anything. The program is all in the Arduino there. And so let's stop that. The device that's making that possible, or our new one, we are putting in the store, and I've been working on this program. This we are calling a CANDue, and it does have to do with running chargers, but it has a lot more to do with the control area network. Polo designed this for me. It has a 256 kilobyte EEPROM chip in it to save persistent variables. 2 CAN bus ports, one of them with a DB9 connector, and one of them with a screw terminal connector. As I said, this one just terminates in 2 wires. I can simply plug that in there and use that CAN port. I got the DB9 to go with this cable, which terminates in a J1962 Type A connector. Now, what's that? That's the connector that's under your steering wheel, usually hidden somewhere, for OBD2. And so this will be easy to plug into the OBD2. In fact, pins 6 and 14, I think, are the CAN high and low, but 16 is 12 volts and 4 is chassis ground. And so I can actually get vehicle power to this board and thence down to the Arduino to power the whole thing from the OBD2 connector. And we're going to use this to log CAN bus traffic off of the OBD2 connector on vehicles such as the Smart ED and the Coda and the Volt. And as you can see, this card simply plugs in to a Arduino DUI. Arduino DUI is a very interesting device. The Arduino was developed as an educational device to show students how to use multi-controllers. It's attracted a lot of people that are, I wouldn't say non-technical, but they're just learning how to use software and hardware to do things. They introduced the DUI. It's a much more capable 32-bit, 84 megahertz Core 3 ARM processor, the SAM3X, that's about 10 times as powerful as the original Arduino. However, it uses a 3.3 volt power supply, and the Arduino had used a 5 volt, and it makes most of these, and they term these shields, circuit cards that plug into the Arduino to do various things, and they have them for any number of things. So the Arduino DUI it's a little bit different to program, not too much, but most of the shields don't work with it. You have to have shields that are specifically designed for it. And so it hadn't really caught on, but it's a fabulous processor and device. So we made this one, and Paulo kind of did this for me. I have the DB9 connector, so I can plug in this cable. And I could make a DB9 connector to connect to anything. This is a terminal strip that has 2 terminals, one for 12 volt DC and one for ground, and then 2 others that are CAN high and CAN low. It has one other thing on here, and that is a micro SD card slot. And we can get these little micro SD cards. They're typically used in cameras like the Hero 3 and so forth. Very tiny chip cards that they have them up to 256 gigabytes of storage on these little cards, and they read and write very fast. And so we can put a card in here, and in doing so I have kind of an unlimited amount of file area to log data, CAN data, and CAN can make some huge files in just a few seconds, and so I need that. I can make those, take the card out and go put it on my PC and suck it into Microsoft Excel or another CAN analysis tool. And so we'll use this for capturing CAN traffic on modern automobiles and trying to reverse engineer some of how they work, so we can bend them to our uses. And we've got this in the store now. I just got them in. They do have the gender wrong on the DB9, so we're going to keep about 20 of them. I picked up some gender changers, which are just little devices to change that. We're sending the rest back to be reworked. But we have these in the store. I'm going to sell the kit for $150. Which includes the Arduino DUI board, which they run $50, our shield, the gender changer, and this cable that plugs right into the OBD2. Now, why do we want to do all that? Why do you want to do all that? Why would you care? This is a charger out of a Chevy Volt. It's actually made by a company called Lear in Michigan, who was most famous for making seating for OEM cars. But they wanted to get into something a little higher margin, and so they developed a charger. And this is a water-cooled charger. It's quite high quality, 3.3 kilowatts. And the Coda also used this charger, and we get 2 of them with a Coda. And I had bought some of the Coda electronics, and so we have a small stock of Lear chargers in. I bought this on eBay for $445. And that is essentially the future of components. There's nothing wrong with this. It was in a wreck. But if it worked before, it'll work again, and it'll work for many years. And it's unlikely anything happened in the wreck to at all disable it. And so 2 years ago, as I said, our chargers, the exchange rate had gotten to where they were up to $3,700. As a result of the bankruptcy of Azure Dynamics, we picked up a large lot of those, very right, and we sell those now in the store for $2,000. And they're OEM quality programmable charger. These Chinese chargers, I can get those to you, a 4 kilowatt one for about $1,800 with my little system to control it. 3 kilowatts, more like $1,150. This charger is better than any of those, and I got it on eBay for $445. The problem is nobody knows how it works. There is not any information about it on the internet at all, anywhere. We have looked all over. We can't get a spec sheet, a brochure, a photograph, nothing of these Lear chargers, but these are used in the Chevy Volt, the Smart ED, the Coda, and probably the Chevy Spark. I'm not certain on the last one, but they'll be readily available as these cars are wrecked and salvaged and parted out. The people that part those things out normally are looking for things like engines, and they do a lot of body panels and piece parts and so forth. They don't really even know what this is. They'll often have it under the wrong name, but if you get to where you can recognize it, they don't know what to charge for it. And so this type of OEM grade equipment can be available quite inexpensively. We have formed a team, Byron Isenbard, Mark Weisheimer, Brian Cochin, and I suppose I'm tagging along as den mother, mostly following what they're doing, to reverse engineer the CAN commands for this. Now, they may be a little different for the Chevy Volt version from the Coda version, but they have the Coda pretty much working now. In fact, I took some of their data, wrote another little charger control program for the Coda Lear charger and sent it to Mark yesterday afternoon, and we'll see if that works, but it should be made to work pretty easily. And so you need something to send CAN commands to this to get it to work. We also have to track down these connectors and the part numbers for them and the pinouts for them. And so there's a little bit of work to doing all this, but the reward is essentially an unlimited supply of very high quality, very low priced chargers out of the salvage network. And this is why I've been kind of on about right to repair and information about these components. It's after nobody wants them. This is after the guys that take wrecked cars and part them out on eBay. This is what they're left with. They don't even know what it is. And we would like to be able to use them, but the manufacturers consider that proprietary data. Okay, it just makes it more valuable when we reverse engineer it then. This is a silly game, but I'll play. But we need some basic tools, and you need some basic tools so you can play too. So we have taken the Arduino DUI and the this shield, which we're calling the CANDue, and a cable, and put that together for $149 that lets you send and receive CAN messages. And then you kind of decode them, you can log them, and so forth. This is a tool to collect CAN data, but it's something more. With this same device, we can put this in a little enclosure. Again, it gets its power over the connector, and we can put this up under the dash running a program. Oh, what might it do to send CAN data to control the gas gauge on our instrument panel, or to get temperature data from the engine. We could log every aspect: our speed, our RPM, our temperature, battery voltages, currents, in every drive for the next 10 years on one of these little SD cards. And so this is basically a CAN tool. Of course, we have the JevQ, but it's $600 by the time I put it in a nice enclosure, have a cable made for it. It has hardened inputs and outputs. It's designed to control a car. This is just a little CAN tool, and we can take a cable and two boards, and give that to you for $150. And you'll be able to write software. We will have programs available, and so you can try your hand at reverse engineering things, or in simply, I'm sure we'll have a whole stable full of things, software programs that come out for this, just to do specific things to a car that people have come up with. And we'll put up a forum for CANDue, and where you can share those programs and so forth. But that's kind of what I've been preoccupied with really for the last month or 6 weeks, is some of the software development and having these actually productized, sent off to China and manufactured in quantity, so we can get the price down on them to some degree for you. And that's what we're doing, and I've been quite preoccupied with it. Again, central figure in that with me, Colin Kidder, has recently revised his EEPROM library. He's calling it wired EEPROM now, to make that much more capable. And we've kind of banged heads together on his CANDue CAN thing and have enhanced that rather dramatically. And at this point, I've got about a 40-page book on this shield done. Instead of a little bit of Chinglish, I've actually written about a 40-page book in English showing you different things you can do with this and how to use Colin's wired EEPROM and CANDue CAN libraries to do useful work and log data to this device. So I'm pretty excited about it. We're doing a number of things. One of our super secret ones is we're going to do our own version of the Arduino board, because the Arduino has some things I don't like. And most of them having to do with USB ports. Let me see if I can peel this apart. Here are two micro USB ports. They break off very easily. We're going to convert those to the big square USB-B ports like we have on the JevQ that are much better. There's also a little barrel jack here for your 12-volt input. You can power the Arduino from the USB port, 5 volts, or by putting 12 volts in here. Of course, as I said, we've got 2 pins here for that, but the Arduino board we're having made replaces the barrel jack with a similar 2 pins where you can bring it in right there for a project that doesn't use this shield, for example. And so that's what we're playing with a lot right now, really in kind of a product development mode with software and hardware to make CAN tools that are affordable and effective for you to use. And the mission, the object there, is to get low-cost, OEM quality components for your car out of the salvage slush pile at very attractive prices, and yet they're actually better built and better equipment as a charger than what we've been used to dealing with. And I think if we pursue that with some vigor 2 years from now, we'll see the ability to convert a car for under $10,000 and at essentially OEM quality stuff. Yeah, but the trick is the CAN tools, and that's what JevQ is about, and that's what CANDue is about. And we're going to continue down that road to make that happen. Stay with us.
Making electric boats isn't just making boats cleaner, it's making boats better. Being out in an electric boat means you can enjoy the environment you're in. You are so much more immersed in the sound and the experience of the aquatic life, of the water, of the wind, than you would otherwise be. And it really gives you a new level of understanding and enjoyment of that generally beautiful nature area you've gone into to enjoy yourself. What an electric motor does is that it gives you oldest power in a vibrationless, soundless way. A well thought out, well designed system has 100% of the torque available all the time. You don't have to build up to it, you have it. So when you pump the throttle, you are out there and your whole shot is amazing. It takes your center of gravity right out from under you, and it gives people that what they call the EV grin. You just start laughing, you can't help it. You're so conditioned to think that you first need vibration, then need noise, and then you start going somewhere. And in this case, your center of gravity just shoots right out from under you. And it's a wonderful feeling. You can still talk to each other. You're hearing the sound of the water and the wind and the waves instead of just hearing engine noise and vibrations. And it gives you really a chance to be in tune with that nature that you're actually out there to enjoy. Plus, not having to visit the pump is actually a great thing. Your battery will eat electricity from any source that you provide. I mean, who loves sitting around on your knees with a jerry can? We have better control over the boat. We have a better experience while we're out driving. Plus, we also have the knowledge that we're part of new technology. It is just way cool. Our mission is to make beautiful, fast, and fun electric boats. There's nothing more fun than taking these new technological developments and putting them into classic designs and having people shoot away with a big smile and an EV grin.
Well, that is cool. That opens a lot of possibilities.
It does.
You know,
The immediate and I think comprehensible example is the chargers.
Absolutely.
The Lear chargers come to mind. Of course, the TCCH chargers are able to be controlled by CAN. But there's other chargers as well, and increasingly this is becoming the case with both chargers. We also have a Delphi DC to DC converter that's like 1,200 watts. It's water cooled, but it has to be CAN controlled. And so this device, it gives us the ability to do that, but it also gives us the ability, or you the ability, or you and us the ability, to log and capture CAN bus traffic and thereby be able to analyze it and determine how these things work, because Chevrolet and Tesla and Nissan don't really want us to know that.
No.
We do want to know it, and believe it or not, you can work it off. We're offering this as a product that consists of the Arduino board, the CAN bus board, which, by the way, has a micro SD card receptacle on it.
Yeah.
That's kind of cool. The cable, and unlike many of the shields and things that you see on eBay with Arduino, this one comes with some documentation. Right now we're printing them, but we'll always have an updated version of this manual, which is right now 37 pages, describing how to work the SD card file system, the EEPROM, and of course the two CAN buses to do your bidding. And so that's what I've been up to on my summer vacation.
Yeah.
But that leads, the chargers are an example, but motor controllers, inverters, all manner of things open the door there. Again, JLD's 505 has CAN,
Yes.
and I could pass data from this to that and from that to this, and then there's a Bluetooth port that can go to the phone or the tablet. And so we're starting to get into some instrumentation and control devices that will, I hope, open a treasure chest of OEM class components at junkyard prices.
That's right, at Sanford and
for
Son
us
prices.
to use to make better builds cheaper, less expensively. And so that's what I'm on about. Rain, tell me about your pump.
Well, you know, these are the Pierberg pumps that we have, and they come with our kits now, our cooling kits. You can also buy these. on the website, and you know they come standard with the barb fittings, and we've never been real fans of barb fittings. They just
And
they
the
tend to
hose
leak.
and the hose clamps.
You got hose and hose clamps, and they're kind of unwieldy. And what we try to always use is the the Army Navy, the AN fittings, which just really don't leak. I mean, we really, unless we forgot to tighten them down, I mean, they just don't leak. So we have experimented with these pumps in being able to put tap threads into them, and they are 3/8 NPT. The problem has been holding these and making sure that we get it exactly perpendicular, only taking out the right amount of thread, having a sharp tool. So we gave it to Lucien, and I said, Lucien, do you think you could tap some holes in these and tap some threads in these? He said, well, give me one of the tops of one, and we'll see. Well, by goodness, Lucien, after a day or two, brought it back to me with threads. And so now we have, instead of having to try to convert, the hose clamps, and that was what, 3/4 inch hose, so then we had to put a reducer to be able to go to 3/8. We can go directly with either the 3/8 to AN6 in the case of that kit, or the 3/8 to AN8 in the single and dual circuit for our larger cooling. And if you don't need to use them, hey, it'll have the threads. If you still want to do barbed, that's fine, but the pumps will have the threads.
I bought those pumps during the raid on Livonia.
Yes.
The Azure Dynamics bankruptcy. They were going begging, and I bought a box of 112 of them.
It was a pallet of 112 pumps.
And I didn't know what they were. They sat back there for a year. And the reason was I couldn't figure out, I know this sounds goofy, this always gets me, is the connectors.
Connectors.
Without a part number or something, there was none on the drawing, none on the part.
No.
I think Paulo finally found the connector number for me. He or Mark Weissman won.
Yeah.
And so we've been able to source the connector that goes in it, and we sell this with the connector and the pins. You have to put together your own because I don't know what you're going to wire.
Yeah, we don't know what you're going to wire it
We'll
into.
give you a little wiring diagram. You got to put 2 of the pins together unless you're going to do pulse width modulator. You can actually run this pump down, I think. What do we sell these for?
Oh, 100 and...
It's going up.
Yeah. We only have about half of them
I think
left.
they're about like $150. What I want to do is still do that, but do an option to provide either the AN6
or AN8
or AN8 as an option, $20 or something. But so we have this, the plug-in pins and the pump. The tuner guys are replacing their engine-driven pumps for these left and right.
Yeah.
And they get them from BMW dealers for $369.
Yeah, these are really
I had
expensive.
no idea what kind of pump this was.
No, we had no idea this was a Pierburg and that quality of a pump.
Yeah, so it's pretty good pump, and we've been using them, and I like them. I really liked the Lang before, but this is probably better.
Yeah.
And so we have... So we'll add that as 2 options.
A couple options to get AN6
is a pair
or
of 3/8 AN6 or a pair of 3/8 AN8s.
Yeah.
And we'll have those all pre-tapped.
Yes, we're just going to get them pre-tapped. So it was. I just never thought of asking Lucien to do it. And we've been fighting with it. We broke a couple of these trying to do it.
Well, this is 2 years later. We're finally getting this pump where it's easy to hook up to,
and then we'll sell out of them.
And easy to use, and then I guess I'll be gone, and we won't need any of that.
Yeah. They didn't even ask for help if we needed help selling them. Put it in the BMW blog, and we declined, guys, so that you could have these pumps at a good price.
Well, there you go. So I think there's a bit of war on with manufacturers now making cars that drive themselves, but kind of preventing you from working on them. And we're going to take the other position. There are cars, and we should be able to work on them. There is some serious manipulation of the public psyche by some of these guys about the evil hackers that are going to break into your car and I guess steal your bank account.
I don't know. What are they going to do? Yeah.
You have to have access to the interior of the car, at least initially. I guess you could get in and install something where you could access it wirelessly, but nobody can get in your car and do that wirelessly, except the Tesla, which I guess they could
proven.
hack the website and be able to get in there. But that's the concept. The hacker is a red herring to keep you from being able to access your own components, make modifications to your car, and more seriously, be able to repair them.
Right.
And I have to tell you, one of the reasons for this is that, would you believe, a large percentage of our population and a large percentage of automobile owners have never, ever once bought a new car.
Sure. Yeah, I could believe that. Yeah. Yeah. Probably never have. Yeah.
We just, when I was growing up, we just didn't buy new cars.
They're
bought used
They're
cars.
expensive.
And
they'd appreciate.
So the problem is that unless you want to pay ridiculous prices for maintenance to Tesla, BMW, and Mercedes, you need a car that you can work on and repair. Because you're going to be acquiring them, many people, after their initial glow is faded.
Yeah, a little the patinas.
Where the rose is faded just a bit
just a
in the
little,
sunlight.
Yeah.
And that's a very normal thing, and I think a very legitimate one. And I don't think, I do not approve of this concept of disposable cars that can't be repaired like televisions. And so that's what a lot of this is about. The other part of it is simply to access a great bounty of perfectly good parts. You know, in the past, when you had a junk car or a wrecked car, how many miles it had on it had a lot to do with what, you know, the value of the parts were. Some of these electronic components, the charger, the inverter, why would I care?
Yeah, who cares? Yeah, they don't really get miles.
It's a little different. Most electronic devices have a function of they'll either quit in the first 30 days,
right,
or they will work for a long time, based largely on heat dissipation issues. There are some special cases, electrolytic caps and so forth. Some devices are just like designed to run 2 years and expire.
And then that's it,
the
yeah.
caps dry out and die because they were cheap.
Yeah.
But
Yeah.
even then, you can break in and replace the bad caps with better ones.
With better and new ones, yeah.
And go on and continue. You almost don't have to troubleshoot some of these small, you know, Wi-Fi devices and stuff. You just open it up and change all the caps.
Yeah, that's right. Just change
It's a
it
safe
out.
bet.
Yeah, that's right.
And that's kind of, you know, part of the art of repair. And that's where we're at on that. I don't have anything to add. And they're sleepy and they're tired of hearing from me.
No, we should,
and I do go on too long.
Maybe we should close with a lullaby.
Okay, it's over. You can go back to whatever you were doing.
All right.
See you
Done
next
all
week.
we can do. See you next week.
We're done.